Okay, let's continue on to Fleming's left-hand rule. All right, you find the Fleming's left-hand rule. This is the Fleming's left-hand rule worksheet. Okay, for the Fleming's left-hand rule, okay, let's take a look at question one. This is a continuation of the previous question here. Okay, this is actually the same question, but we're going to use the left-hand rule to show you to prove that when you put a electromagnet or a conductor that has a magnetic field inside a permanent magnet, it's going to move up here like this, like this catapult field here. All right. So a bit of revision on your Fleming's left hand rule. Okay, if you take a look at your notes, this is your left hand. Okay, you must be familiar with what it represents, FBI. All right, so force, your thumb represents the direction that your cable is going to move. If your cable moves upwards, your thumb points upwards. If your cable moves downwards, your thumb moves downwards. Okay, so what about current? Current is just the conductor, all right, the direction of the current. If it's moving left to right, then your finger will point left to right. If it's moving right to left, then your finger will your middle finger will point right to left. So you need to be familiar with this. FBI, just remember it's FBI. Magnetic field is just north to south. Your finger always points from the north to the south. All right. So let's take a look at the example, the question that we're supposed to do, which is this one here. So using this question, I'm not going to draw magnetic field lines. I'm going to predict which direction this cable, all right, is going to move. Is it going to move upwards, downwards, sideways, up or down, or in or out of the page? Okay, so either one of them. So let's try using FBI. So using the FBI rule, so if you move your right hand and left hand, F, your thumb is pointing upwards. Magnetic field, all right? Your magnetic field is pointing from, in this case, is pointing from, since remember your permanent magnet, okay, this magnetic field is talking about the permanent magnet, by the way. Your forefinger should be pointing to your, in the direction from north to south, right? So your finger points here. Okay, you can put it parallel to your screen. Your finger points here. This one here, okay, this is a tricky one. This one here, the current is coming out of the page. Okay, so what you're going to do is you're going to take your middle finger and you're going to point it, uh, my drawing here is wrong, it's 3D. Point it towards you, all right? You're going to point it towards yourself. Okay, so this is a bit tricky to do. Okay, your magnetic finger, the second finger, you're going to point it facing your screen from left to right, and your middle finger, you're going to point it towards you. It should be pointing towards your mouth. Okay, so all of them should be 90 degrees to each other. Okay, make sure that your second finger and your middle finger are pointing 90 degrees to each other. Okay, and then finally, where does your thumb go? Your thumb is actually to your second finger. It should be like this, right? Your middle finger should be pointing out the page. Your thumb should be like this, 90 degrees. So your thumb is actually pointing upwards. All right, your thumb can only point upwards because of this. Okay, this is a bit tricky to do, but with practice, you get it right. So that's how you actually use Fleming's left-hand rule. Okay, and this actually confirms our answer with the magnetic field lines. It's actually pointing up. Let's take a look at another example of Fleming's left-hand rule. This time I want to go back to your notes. All right, this notes here, and I want to try this question here. Okay. So it says using your left hand rule, state which direction the wire will move. So in this case, the north and south poles, or rather the permanent magnets, are arranged vertically, all right, instead of horizontally like just now. And the current is passing to your, from left to right. So I'm going to do this again. What you're going to do is you have three fingers. Let's start with a magnetic field. Okay. Remember I just told you that this finger here, okay, the magnetic field is always for the permanent magnet. The permanent magnet, not the electromagnet. Okay, the permanent magnet, which in this case is the north and south. Remember, north to south pole. North, I remember I always tell you in class, the magnetic field lines always goes from north to south. So in this case, what we're going to do is use your second finger, point it downwards. Okay, down on the screen. All right, that means it should be pointing down your screen. Okay, and your middle finger, all right, Okay, this is a bit tricky. You might need to rotate your hands a bit. Okay, a bit of hand gymnastics. Your middle finger, point it to the right hand side. You might need to remember it's your left hand, so you can't see it here, but I'm actually twisting. I need to twist my wrist. So your middle finger points here, right? Because the current is going from left to right. Okay, your middle finger, the current one, middle finger, points here. Okay, now you need to determine which direction that the cable is going to move. Okay, and without breaking your finger, your thumb, okay, stick out your thumb. All right, your thumb, stick out your thumb. You realize that your thumb is actually pointing inside into your computer or your handphone screen. All right, your thumb is actually pointing inside the screen. So basically, if you have done everything correctly, this cable, this wire here, will be bending inwards. All right, I can't draw it here because this is a 2D image, so it's going to bend into the screen.